Hello everyone, welcome back to Math Jamboree. In this video we have another AP Precalculus type of a question from the polynomial and rational functions. Let's solve it together. A polynomial function p of x is given by p of x equals x minus 1 times x minus 4 times x plus 2. What are all intervals on which p of x is greater than 0? Choice A, B, C, D are given. To solve these questions, this type of questions, these are the factors of the polynomial, and we will need to find its roots. To find the roots, we're talking about roots, we will just make each factor equal to 0. So, x minus 1 equals 0. From here, the value of x will be equals to 1. If x minus 4 equals 0, the value of x will be equal 4. For the third one, x plus 2 equals 0, then x will be equals negative 2. Sorry about that. So we have we have found 3 roots. Let's put them over here, diagram sign, and put them in order. Negative 2 comes first, 1 and 4. And we have 4 different regions now. We will look for the greater than 0 section. So I'm going to use some test points. In this region, I'm going to use negative 3. Between negative 2 and positive 1, I'd like to use 0. Between 1 and 4, I'm going to use 2. After 4, I will use 5. These are our test points. These are going to give you an idea about the polynomial, whether this polynomial is positive or negative in these regions. So p of negative 3, if you will put negative 3 for x, negative 3 minus 1, negative 3 minus 4, negative 3 plus 2. This becomes negative 4 times negative 7 times negative 1. And this turns into negative 28. So in this region, the value of the polynomial is negative. Let's check for p of 0. I'm going to substitute 0 now for x. Therefore, this becomes 0 plus 2. And this is negative 1 times negative 4 times 2, which is positive. So in this region, the sign of the polynomial is positive. And for the p2, we will substitute 2 for the x. Therefore, this becomes 2 minus 4, and this becomes 2 plus 2. 1 times negative 2 times positive 4. This is negative. I didn't put in the previous one the value because you really don't need it actually. This equals positive 8, this one is negative 8. You don't need to find the value. All you need is the sign. So for the p of 5, we will substitute 5 for the x this time. Therefore, this becomes 5 plus 2. And this is 4 times 1 times 7, which is positive. Positive 28. So we have 2 regions. They said that greater than 0 of the function, which is positive. But be careful with that. It's not greater than or equal to. It's just greater than. So in these regions, the value is positive. So between negative 2 and 1 first, do I include negative 2 and 1? These are the roots, which means that these values makes polynomial 0. We will not include because it's not greater than or equal to. We will just use parentheses. Union and 4. Are we going to include 4? No, because greater than only. And positive infinity. This will be our final answer. If you will look at the choices, for instance, in choice A, they included -2 and 1 and 4. If this would have been greater than or equal to p of x, let me write it more clear. If this p of x would have been this, the answer would be A, but it's just greater than. That's why it's not the answer. This is known. Between negative infinity and -2, the sign of the polynomial is negative already, so we're looking for the positive area. The choice D is the answer we're looking for. This is how you solve this problem. I hope you found this video helpful. If you did, please give it a thumbs up. If you have questions or comments, you can always leave it below there. Thank you and see you next time. Bye-bye.